This is Travis Policino and Jack Crowley, and we did the polar ice caps biome.
The location of the polar ice caps are around the Earth's poles, and these are massive sheets of ice. The biodiversity of the ice caps is much less than that of any other biome, as there is a very large lack of plants above water and a freezing climate. Many of the species within the polar ice caps are cold-adapted fish, mammals, and birds. And they have adaptations such as thicker skin, shorter legs, blubber, and white coats. The abiotic factors of the polar ice caps include soil type, which is either non-existent or buried by ice. Non-existent in the case of the North Pole, as that is a massive ice sheet over water, while in the South Pole, it's over a continent. Rainfall is usually snow. The temperature is an average annual temperature of negative 17 degrees Celsius. The light is because of the tilt of the Earth's axis. The polar ice caps will have 6 months a day during the summer and 6 months a night during the winter, making it frigid. And the salinity is 4 parts per thousand because of the amount of ice. The weather and climate. The weather patterns are usually snow when there's precipitation. It builds up as it very rarely reaches a high enough temperature to melt, and the temperature is almost always below freezing. The latitude effect. The latitude of the polar ice caps is always at the poles. Because of this, the biome does not get as much sunlight, and this makes it very cold. And the altitude effect comes from there are very large high plateaus on ice caps that alter storm tracks and create cold downslopes as well as cold tops. And within the ice caps, there's also large mountains of ice that have freezing peaks. Decomposers in the Arctic are rather rare, so scavengers pick up the slack. One of these scavengers is the ivory gull, or Pagophilia eburna. So their adaptations include the white color for camouflage, a thick plumage for warmth, smaller size as less food may be prevalent during the winter, a smaller build, and shorter legs to conserve heat. These shorter legs and smaller bill are completely different than other birds of similar size.
So there's also protists in the Arctic, and the one we're looking at is a type of algae called pennet diatoms, and they live in brine channels, and they can also secrete osmolytes, which allow them to survive in high salinities as well as low salinities. So basically any part of the Arctic ice. There's also many plants in the Arctic. The one we're looking at is Papaver radicatum, and they have a hairy stem to retain heat. It works almost like fur, and the flower can also track the sun and sky, and it can move along with the sun to maximize the amount of sunlight it receives so that it can increase photosynthesis. For arthropods, there are things called springtails or columbola, and they're small wingless insects that live in the Arctic tundra. They feed on decaying organic matter as well as fungi. Their adaptations are that they can survive for several years while frozen. They have a very large tolerance for dehydration, which allows them to survive when there's not much liquid water. And they can take advantage of small increases in temperature, so their body can sense when there's even the slightest increase in temperature, and that's when it'll move and feed and everything. In terms of exothermic animals in the Arctic, or reptiles, there aren't any because the heat given off in the Arctic simply isn't enough for them to survive, as exothermic animals rely on taking in heat from either the sun or rocks or any sort of heat source, but there isn't enough heat in the Arctic, and there just isn't enough heat from the sun for them to survive. For endothermic animals, we're looking at the ringed seal, or Pusa hispata, which is an earless seal inhabiting the Arctic and subarctic regions. Their adaptations is that they have claws to dig breathing holes when they're far away from shore, which means they can swim out further than other seals, as they can dig air holes through the ice. They have blubber to help them keep warm in the cold, and they have a high red blood cell count so that they can stay underwater for longer as their body traps more oxygen.
So symbiosis. So for our version of symbiosis, it's a picture of an Arctic fox following polar bears. They often do this as the polar bear will leave part of the kill that it no longer desires. Therefore, the fox will eat it. This is an example of commensalism, as this is a symbiotic relationship in which one species benefits, the Arctic fox, while the other species is not affected, the polar bear. For our human-created problem number 1, which is the warming of ice caps / global warming is the process of the planet heating up slowly over the course of many years. This is caused largely by the high release of greenhouse gases from the burning of fossil fuels. This threatens the biome because it melts a large number of ice in the ice caps. Animals like polar bears may become stranded on these ice caps, so either the habitat leaves them or they leave the habitat. Solutions to climate change are impossible as the damage to our atmosphere is irreversible, but we can slow the damage by switching to cleaner energy alternatives, and maybe one day we'll be able to fix the problem.
So human-created problem number 2 is plastic and other types of trash in the ocean. And plastic pollution has reached the polar caps, which is really showing how far our plastic pollution of the oceans has gone. And the result of it reaching the ice caps is that there's deaths of hundreds of animals that mistake the plastic for food. This also has a long-lasting impact because microplastics are what can start killing plankton because the plankton mistake them for food, which plankton are on the bottom of the food chain, so it affects every animal. Solutions would be to reduce the amount of plastic we use and the amount of trash we throw away. And also, we can start switching to reusable containers as well as helping to clean the ocean and take our trash out. The third human-created problem is overfishing, and overfishing is when the population of fish in a certain area is greatly reduced by large amounts of either commercial fishing or private fishing, and this can cause problems for the whole food chain as too many fish are removed from the environment all at once. It's faster than they can replace. And solutions may consist of higher regulations around fishing and stricter fines, as well as more people to enforce the regulations.
This has been the Polar Ice Caps, and I'm going to sleep.
Have fun.